Hey guys, welcome to our video on chapter 4 for mass, weight and density. Okay, so in this chapter we are basically just going to answer a couple of questions. Alright, we're going to ask about weight, we're going to talk a bit about weight. After that we're going to talk about inertia and we'll end the chapter. To answer this question, why does an iron ship float while an iron ball sinks? Okay, let's look at mass and weight. Okay, like what we mentioned earlier. Okay, so sorry, before we actually continue, let's turn to page 70 of your textbook. Okay, what is mass? Okay, mass is basically the amount of substance or matter in the body. Do highlight these words. Okay, basically matter means anything that is substance. Substance is made out of atoms and molecules. So mass actually does not change with its location or shape. Depends on the number of atoms or molecules inside that object or body. And the SI unit for mass is the kilogram. Okay, so you can see over here, mass is basically anything that has matter or anything that has atoms or molecules. Okay, so what about weight? What is the difference? Okay, weight, as you can see, mass is talking about the amount of matter, whereas weight is the first time we have this word force. Okay, weight is the gravitational force acting on it. So which is why on the moon or on the earth you can have the same mass, because you can have the same, let's say if we are to move to the moon, or a space rocket is to fly to the moon, the same space rocket here on earth and on the moon will have the same amount of matter or same amount of atoms or molecules in it, which is why the mass is the same for the space rocket, whether it's in the moon, on the earth, or even in space. Okay, but the weight of the rocket changes because the gravitational force acting on it determines its weight, and we know that gravity is the concept. Gravity is the concept that actually exerts a force. Okay, excuse me on that. Gravity is actually it actually exerts a force. It's due to gravity that we actually have a gravitational force acting on a body. Okay, so earlier we mentioned that mass, the SI unit for mass is the kilogram. Let's look at weight. So weight, the SI unit for weight is the Newton, because that's what we learned in Sec 1. Since it's a force, the SI unit for forces are newtons. Okay, and force over here is a vector quantity, so the direction of weight is always downward towards the center of Earth. Okay, or if you're on moon, it will be towards the center of the moon. Okay, so we'll talk about why does an object actually have a gravitational force acting on it. We all know about gravity. We all know it's due to gravity, but what exactly is gravity? So what is a gravitational field? A gravitational field is a region where a mass experiences a force due to gravitational attraction. Okay, so that is gravitational field. You have a stronger gravitational field over here on Earth than that on the moon. Okay, whereas in space the gravitational field is zero. Okay, how do we talking about zero? Okay, so in other words, we can actually measure gravitational field. How do we measure that? Okay, so gravitational field is measured using the strength of gravitational field is known as gravitational field strength, and the gravitational field strength is defined as, to underline this, the gravitational force acting per unit mass. Okay, so the weight actually depends on the strength of the gravitational force. The mass will be the same whether it's on Earth or on the moon. Okay, and the gravitational force again depends on the mass of of the planet that we are on. So on Earth, the gravitational field strength is about 10 newtons per kilogram, and you notice this same number is actually the same as the gravitational acceleration due to gravity. Okay, so on Earth, the gravitational field strength on the moon on Earth is 10 newtons per kilogram, whereas that on the moon is 1.6 newtons per kilogram. All right, so since now that we talk about this, before we actually move on to the next part, let me just show you a short video on gravitational field. Why do we actually have gravitational fields? Alright, hope you enjoyed this.